What's up, ladies and gentlemen? Welcome back to Neurosketch with Dr. Kenny. But this is the first time you've seen this channel, don't forget to subscribe. Let's talk about the cerebral white matter, but as always, let's go back to this picture over here. So we say the cerebrum must go two main layers: the outer layer, which is the layer of gray matter, which is also called the cerebral cortex, and the inner layer, which is the layer of white matter. And we say this region here appears white because of the presence of myelin-related axons with the myelin sheath. Yeah, and what is the function of axon? One more time, we say the axon, they are carrying action potential, they are propagating action potential, so they are potentially like wires. And the white matter areas of the brain, they are also like wires. But one thing to remember, the spinal cord has also got the white matter and the gray matter, but the white matter and the spinal cord is on the outer zone and the gray matter is on the inner zone. Yeah, but in the brain, the gray matter is the outermost and the white matter is the inner one, even though we have the deep gray matter within white matter. Okay, so these are the example of white matter regions of the brain. So we have the anterior commissure, but we have the corpus callosum. You can never forget corpus callosum. We have posterior commissure somewhere here, but also have the internal capsule. These are the different examples of the cerebral white matters. So we have three groups of the white matter of the brain, and these groups are called tracts. Yeah, we have association tracts, we have the commissural tracts, and the projectional tract. And the word the tract actually means the bundle of axons. Yeah, different axons coming together, they're forming a bundle of them, and they're called the tract. Yeah, it's like a pathway going to a specific part or transferring information from different parts of the nervous system, carrying action potential, propagating the electrical impulse from one part into another. Okay, so the association tract, what are the association tract? Yeah, these are the tract of fibers that are carrying information from one gyrus into another gyrus, but within the same cerebral hemisphere. Within the same cerebral hemisphere, carrying information from one gyrus into another within the same cerebral hemisphere. This should be the association tract. And then we have the commissural tract. The commissural tract, they are carrying information from one gyrus into a corresponding gyrus in the other hemisphere. Yeah, so for example, you are taking information from the transverse gyrus, for example, of the left hemisphere into the transverse gyrus of the right hemisphere. These are called the commissural tract. Commissural tract. Example of commissural tract, you have the corpus callosum. Of course, we know that it's connected to cerebral hemispheres. But also have the anterior commissure and the posterior commissure. We're going to see them soon. Yeah, so this is the commissural tract. What does it do? It carries information from one gyrus into the corresponding gyrus in the other cerebral hemisphere. And lastly, we have the projectional tract. These are projectional tract. They project. Yeah, so they are carrying information from the cerebrum into the lower part of the central nervous system. Yeah, it can carry information from the, for example, primary motor cortex. It carries this information to the thalamus, for example, or brainstem, or even the spinal cord. And these are called the projectional tract. And one among the very important projectional tract that we know is the internal capsule. Internal capsule. Let me show you by this picture here. So we have said we have the association tract. Of course, they're not seen with this picture, but they are carrying information from one gyrus into another gyrus, but within the same cerebral hemisphere. It does not cross to the other cerebral hemisphere, and it does not go to the lower part of the central nervous system. But we have the commissural tract that are carrying information from one gyrus into another gyrus, or the corresponding gyrus to the other hemisphere. For example, here in the scene we have the corpus callosum. We have the anterior commissure, and of course the posterior commissure. All these anterior commissure, corpus callosum, and the posterior commissure, they are commissural tracts. Yeah, commissural tract. And lastly, we have seen we have the projectional tract that are carrying information from the cerebrum to the lower part of the central nervous system, maybe to the thalamus, or to the different parts of the central nervous system, the brainstem or the spinal cord as well. Example is the internal capsule. We'll have a separate discussion of the internal capsule once we already do the pathway, the sensory and the motor pathways to the brain. Okay, this is your corpus callosum, and remember, corpus callosum is one among the C-shaped structures of the brain. You will later learn that the brain has got a number of C-shaped structures with the letter C. Yeah, so the corpus callosum is one of them. This one here. Okay, it's a C-shaped, and these are the parts of the corpus callosum. You have the rostrum, remember rostrum, and then we have genu, and the word genu is a Latin word for knee. Yeah, so this is like a knee of the corpus callosum, and of course we have got the body of corpus callosum and the splenium of the corpus callosum. Yeah, so corpus callosum is just below the cingulate gyrus. You remember we discussed about the cingulate gyrus and the cingulate sulcus. What is the function of the corpus callosum? Yeah, transmit information between the two cerebral hemispheres. Okay, then this is the internal capsule. Don't worry, don't mind these other details that we have never discussed them before. We're going to discuss them later. The caudates, globus spiders, and the putamen, forget about them. But this here is the internal capsule, and this is the coronal view. When you cut the brain in this section, this is what you will see. And the internal capsule, you see they are projecting inward. They are going like inward, yeah, to meet, like going to meet each other. But this is only in the coronal section. And remember, this is the corpus callosum. So this is the internal capsule, this is the internal capsule, this is the corpus callosum, this is the projectional tract. Yeah. But if you cut the brain in a horizontal fashion, you will see the internal capsule is actually inverted V. You have two internal capsules, one on the right cerebral hemisphere and the one on the left cerebral hemisphere. And on horizontal section, they are, forming the inverted letter V. For example, this is the internal capsule of this side, and this is the internal capsule of this side, inverted V. So it has got two limbs. Every internal capsule has got two limbs. It has got the anterior limb and the posterior limb. So this is the anterior limb of the internal capsule, this is the posterior limb of the internal capsule, and between the anterior and the posterior limb we have a genu. What is the genu again? Knee. Yeah, so this is the knee of the internal capsule. Same applies to the other side, like you have the anterior limb of the internal capsule, posterior limb of the internal capsule connected to the genu, to the knee of the internal capsule. So the internal capsule, as we've said, is one among the projectional tract, and we've said this tract, they are pathways, like these are bundles of axons that are brought together to transmit information between different parts. So when we are going to discuss about the sensory and the motor pathways, you can never ever skip the internal capsule. So we come back to internal capsule, and we'll see. Don't worry about this leg, trunk, arm, and facial arrangement here, because we're going to learn it when you are doing the anatomy, the sensory and the motor pathways of the brain. And this is the section that was taken, like this is magnification of this one, and that's the internal capsule. This is just to zoom it in. Yeah, so this is the internal capsule, and it's sandwiched between the basal nuclei or the basal ganglia. We're going to discuss about them also at some point. All right, folks, until next time, stay curious and see you real soon.